everybody. Welcome to science class. This is our actual science classroom. Hopefully you can join us here one day. I'm Mr. Bullington. I'm here with my friend Chip. Say hello, Chip. Hey, what's up? Oh, thanks, yeah. So this is Chip here. We're going to be working together. We're going to talk to you a little bit about matter and energy. Today, we're going to focus a little bit more on kinetic energy and temperature. You looked in Explore 1 a little bit how energy affects molecules. So let's talk about what is energy. Chip, do you know what energy is? The ability to do work? That's right, Chip. It's the ability to do work. There's different types of energy you may have heard of. Thermal energy, chemical energy. We're going to focus today's class a little bit on kinetic energy. What is kinetic energy? What do you guys think? What's kinetic energy? Chip, kinetic energy? It's the energy of motion. That's right, Chip. It's the energy of motion. This guy's got all kinds of answers. Did you know that matter is in motion? The desk you're working at, it's moving right now. You can't tell. But the kinetic molecular theory, it's a tricky one, say that. Kinetic molecular theory of matter states that matter is made up of particles that are in constant motion. So molecules that are in the solid phase, like this funnel here, have less energy than, say, something that is in the liquid phase or gas phase. So if we want to know how much energy is in an object, what can we do to find out? Does anybody know how we can tell how much energy is in this funnel or in my beaker of liquid here? There's a way that we can do that, Chip. What we do is we actually take its temperature. Just like when you go, say, to the dentist now and they take your temperature to make sure you can come in the door. That's what we do. Pretty quick and easy. Take the temperature, and temperature actually is something that is the average kinetic energy of an object. So temperature actually means the average kinetic energy of the particles in that object. That is what we're measuring when we are measuring the temperature of something. Kind of a cool thing to figure out today. So as substances are heated, their temperature increases, and as that temperature increases, what happens is that the molecules begin to move faster and faster. We're adding energy by adding heat. All the molecules don't move at the same speed. Sometimes the molecules move a little slower, some move a little faster. Most move about the same speed. It's kind of like in PE when you're running the mile. Some kids are in the back, some are in the front, but mostly there's a big pack that kind of moves together. The molecules are the same way. So when we measure temperature, like say with this IR thermometer, that's what we're doing, is we're finding the average kinetic temperature. We're finding the average, the temperature is the average amount of kinetic energy. That's what we're looking for. So, the opposite is also true. If you cool things down, the temperature is going to go down, and then you're going to see a lower average kinetic energy. That's how that works. So we're going to do a little experiment today. We're going to try and figure out the average kinetic energy of a liquid here, which in this case happens to be water. So how do we determine the average kinetic energy of our water? Well, what we're going to do is we're going to take a container of cool water, which is ice water basically that's come out of the refrigerator, and a container of hot water that's come out of my little kettle right here that I've heated up, and we're going to find out the temperature of those two, and then we're going to see if we can't find the amount of average kinetic energy if we combine those substances. So we're going to start off by taking the temperature of the cold water here, and that looks like it's 0.2 degrees Celsius. That's pretty cold. It must have come right out of the freezer there pretty much. So of course we're using Celsius. We'll measure our warm water here. I'd show you, but you can't see it, but it says 68.6 degrees. So those are the temperature of our two containers right here. What we want to do now is we're going to combine them together, see if we can't find the average kinetic energy of the combined liquid that we're going to put in the same container. So, this experiment happens to be brought to you by Willie's Bagels and Blends down on American and Balfour. Stop by sometime. So we're going to use 40 milliliters. I have this graduated cylinder here that helps me measure. This is something you could do at home actually with some hot water and cool water if you had some adult supervision. You just need the measuring cup pretty much. You want to use the same amount for our experiment, so the same amount of hot water, the same amount of cold water. So I'm going to take 40 milliliters here of my cold water. Make sure my device is all level. So there's my 40 milliliters there. I'm going to put that right in here. Then I'm going to take my hot water. We're going to do the same thing. Make sure I can see the numbers. I was going to face them towards you, but that's not going to help me too much. And I do have the funnel to help me pour it, but these beakers have a little lip on them to help us out. So that's what those funnels were actually going to be for. All right, so now I have my container here and I want to find out what's the average kinetic energy of the liquid now. You have a spot on your paper there I want you to guess, to make a prediction. So why don't you predict what it will be before I show you, and then we'll talk about what it actually is. So if we want to find the average kinetic energy, quick little math lesson for you guys. You guys know how to find the average. So we just want to add these together and divide by the addends, which in this case there's two numbers. So we're going to divide by 2. So we add these up, we divide by 2. That'll give us our average for these two temperatures here. And so you're going to put that on your paper, but it also asks you to make a prediction. So hopefully you have that prediction written down. And it looks like our actual temperature after taking the measurement is 30.6 degrees Celsius. It's interesting. It's not exactly in the middle, is it? We did wait a few minutes there before I took the temperature. But yeah, so like we talked about, some of the molecules move faster than others, some move slower than others. So things can move around and change a little bit. On your paper there, one of the things that it asks you to describe is the motion of the molecules in hot water in terms of kinetic energy. So when you are thinking about, if you could see with your microscope eyes into this hot water here, and you could see those molecules, how do you think they would be moving? Would they be sitting still? Would there be a tiny bit of movement, a lot of movement? Remember, this is hot water, so it's going to contain a lot more energy than the cold water. So if we're going to describe the movement of that, we would probably say the movement was very fast. Those molecules are moving fast, they have a lot of kinetic energy. As opposed to the cold water, which would kind of be the opposite of that, right? So when we mix these together, what happened? Why did this number come out at 30 degrees? 30.6 degrees Celsius. Why don't you guys talk about that a little bit? See if you can come up with a good answer. We'll get that on your papers. Turn that in, and I think that'll cover this lesson for the day. So, if you have questions, let one of your teachers here know. Thanks for coming to class today. Chip, anything you want to say? No. All right, buddy. He doesn't say much. See you later.